Greetings viewers, in this video we will attempt Cambridge A-Level Further Mathematics, the Further Mechanics component which is paper 3, and we take variant 1 from May-June 2025 series. We'll go for question 3 now. The previous questions has been uploaded to the playlist already. So this question has a lot of information here, but first let's slowly read it and try and sketch out whatever information that we have. This rough horizontal disc with center O rotates with a constant angular speed of omega radian per second. A particle P of mass 1.6 kg. So just write down somewhere. Mass is 1.6 kg. And this distance is already labeled 1.5 meters. And it's attached A vertically above O with a light elastic string. So this string can be or can be approximated to be a spring lah, basically. So a modulus of elasticity 32 newtons. So I also write it down, modulus, Young modulus 32 newtons. And it makes the angle A or alpha with OA. Okay. The particle P, oh sorry, one more thing I left out here is the natural length or the unstretched length L0 of the string is 2 meters. Okay. Where else? Alpha and particle P moves along this horizontal with speed omega. So it's turning with angular speed omega. P is on the point of slipping in the direction of OP. Okay, it's on the point of slipping. So means it's having the maximum frictional force, which given the coefficient of friction is mu is 0.5. And okay, it's on the point of slipping towards this direction. So we know the friction will act on the opposite direction. So the friction is acting towards the center. Okay, so let's keep that in mind first. Given that the tension in the spring is 8 Newton, show that sine alpha is 0.6. To find the sine of alpha, we're going to need the opposite OP we already got, right, which is 1.5, and then also the hypotenuse, so AP. We don't know what this is yet, but we are given that the tension is 8 newtons. So we can use this information to find how much the string has extended. So obviously if you have the formula, this one, right, if you know this formula, you can straight away use it. I'm going to show you a bit of the derivation behind it. The Hooke's law, stress-strain relation, the sigma is a stress, and the E is a Young modulus. Epsilon will be the strain, and the strain, that is the extension over the original length L0. So this one, actually the units or the dimension is pressure or Pascal or Newton per meter, Newton per meter squared. And tension, the dimension is force. So to convert this into the tension, you have to multiply by the area. So something like this. Tension equals to sigma multiplied by the area. So you have EAX over L0. And yeah, therefore you can simplify even further. EA over L0 then X. So this actually E and E multiplied A, that's your elastic elastic modulus, right? That the dimension pressure multiplied by area, then X over L0. So given this information, we know the tension is 8 newtons, the elastic modulus 32 newtons, extension, that's what we want to find, original length is 0.5. Oh sorry, 2. And you can get X or the extension to be 0.5 meters. So we know AP therefore is 2, the original length, plus 0.5. So this is AP is 2.5 now. Just label it here also. And therefore, yep, sine alpha opposite 1.5 or OP over AP hypotenuse. So 1.5 over 2.5, that 0.6. And therefore you have proven this. Alright, now we go for part B. Find the number of revolutions per minute, so RPM, made by the disk and particle P. Alright, let's draw the free body diagram first, because we need to resolve the forces here. So let's say during the exact, let's say we're looking from here lah. If we're looking from here, we have a particle P, so it's on the surface, right? And we have a string with a tension. Tension is 8 Newton, so it's pulling that way. Then we have the alpha here lah, alpha. Okay, and then we have, obviously we have gravitational force, we have the reaction force, the normal force. Then again, okay, the friction force, it was, okay, it's going to slip in this direction, so the frictional force is acting to the left. So this is frictional force. Okay, I think that's all the forces that we accounted for. Now we look at the kinetic diagram showing the resultant forces. So in the vertical direction, there's no resultant forces because it's not moving up or moving down, but it is rotating. So we have to consider the what is it called, the centripetal force. So there is a centripetal force or resultant force into the center of the disk. So maybe let's just write here. Here is O lah. So it's towards O. Okay. So this is the forces. Free body diagram represent all the forces. Kinetic diagram represent the sum of the forces, or the resultant forces. Not the sum, the resultant. Yeah. Right. Okay. So let's assign our axis first. Maybe I'm gonna do left is positive in this case, because all of our horizontal forces resolve to the left anyway, so we can assign that to make our life easier. And obviously up is positive, down is negative. But yeah, it's not gonna be mattering so much, because in the y direction there's no resultant force. So Newton's second law state, or this is the first law, right? Inertia. So there's no resultant force, so it is 0. The sum of forces equals to 0. We have up is the new reaction force or normal force. Down is, or up we also got, right, the tension. We need to multiply by cosine of alpha, because this tension we can resolve it to its horizontal and its vertical components. So t x and ty. So tx, sorry, this is vertical direction. So ty is touching the angle, is adjacent to the angle, so there is cosine. And cosine, how do we find it? We already got this is 2.5. We've already proven in part A. So this OA, you can use the Pythagorean theorem, 2.5 squared minus 1.5 squared, and then you square root it, that will get you 2 meters. So cosine will be 2 divided by 2.5. We will use that later. Minus mg is going downward. So isolating everything, g we use 10. G gravity 10 meters per second. I also forgot this syllabus using 10 instead of 9.81. So take note for the physics. People who take physics, please take note on this. Tension is 8 cosine, or maybe I rewrite everything first. Rearranging mg minus t cosine alpha. So mg, you have 1.6 times 10. T is 8, cosine is 2 divided 2.5, and you get 9.6 newtons. Okay, so the dimension is a force, so it's a newton. So don't confuse with the variable n here. Okay, next we resolve the forces in the x direction, or the horizontal direction, which you have a resultant force of the centripetal force. So the centripetal force, if you forget, centripetal acceleration is in the formula sheet here. Yeah, motion for uniform circular motion, the acceleration is this one. And so since we actually want to find the what we call the angular speed, so we'll just straight away use this instead of the other one, the tangential speed. So it's equal to m omega square r. The sum of forces in the x direction, let's see what we got. So first we have the FF, yeah, going to the left. Also we have the tangent or a tangent in the x direction, then equals to m omega square r. So these only two forces in that what we call the horizontal direction here. FF, you remember the formula, you have to memorize it actually. Mu n, that's friction force formula. The coefficient of friction multiplied by the normal force. Then T or the horizontal tension, there will be T sine alpha lah. So sine alpha, we've already proven it just now, 0.6. So we use that later. M 1.6 again. Omega square is something we want to find, so we leave it. R is the radius. So radius given is in the question also 1.5 meters. Okay, now we just substitute the values. Up till here, we get omega square is 4. So depending on, okay, actually the question did not specify which way it's turning, right? So it did not specify which way it's turning. So actually, it does not change how we approach the question lah, because either is going the positive or negative, it does not affect the magnitude of the free body diagram or the kinetic diagram, and you will still have the same value here. So yeah, it doesn't matter unless they want us to find the direction, but it did not specify. So you just take the positive as the magnitude, okay, the magnitude of the omega, 2 radian per second, and we want to find it in revolution per minute RPM. So we do the unit conversion, so radian per second, 1 revolution, you have 2 pi radian, right? 1 revolution, there's 1 circle, there's 2 pi, the angle that it turns. Then per minute, you have, or sorry, wrong way around. Per minute, you will have 60 seconds. Yeah, like that. So the radian cancel, second cancel, you're left with revolution per minute. So it's 60 divided by pi RPM. Yep, and that's the final answer. So I think they want us in, probably just better give it in the numerical value, 19.1. So did not ask for the exact form, so it doesn't have to be. Okay, so it did not ask for the direction also, so it doesn't have to give also lah. So this will be the final answer anyway. Yep. Alright. So yep. Thanks for watching.